Good evening, everyone. Today, we have assembled to understand two things as a part of extended learning in artificial intelligence and machine learning. So, our today's topic is going to be understanding the basics or fundamentals of machine learning, and also we'll see how to implement one of the most popular and simple machine learning concept, which is called as decision tree. I'll be sharing my screen with you, and then the presentation will help you to go step by step with me. So this is our today's presentation that we will be following. Now, as I have told, this presentation takes care of two parts. One is machine learning, and then out of it, one specific model, which is called as decision tree. As you can see by name itself, it is a tree which will help us to take some decision. Let's move forward and understand. What is machine learning? Machine learning is basically that field of computer science with the help of which computer system can provide sense to data in much the same way as human beings do. So if you have collection of data, and if you can find some sense out of it, and you can do a specific task with the help of computer or programs or software or hardware, we can tell that the machine is able to learn. From where it will learn? It will learn from the data. That's what we are talking about, sense to data. Machine learning is a type of artificial intelligence that extract patterns out of raw data by using an algorithm or method. So data is must, and then you will apply some algorithm. As we know, it's a step-by-step process to understand or solve some problem. So you need to have collection of algorithm, need to have some data, and applying that, you will make a machine to learn, and that learning machine can do something, and also in future it will be keep on learning by its own. The key focus of machine learning is to allow computer systems to learn from experience without being explicitly programmed or human intervention. So it should learn from experience, and then it will take a decision what it is supposed to do. All these things, if I'm able to do in a specific particular field of computer science, I'll be speaking that I'm dealing with machine learning. The machine learning applications are a lot. You can see a lot of items have been listed here. I'm not going to explain each and every one out of here, but a couple of them you can understand what is there at your screen. As for example, weather forecasting and prediction. A machine learning can help you whether today evening it is going to be a stormy evening, it is going to rain or not. Stock market analysis and forecasting. And remember, without human related activities, the program or software, it will do by its own. It can analyze the stock market and forecast for you. See, these are the firms or list of firms where you please invest your money. So it will be very helpful for the people to get better benefit. How it is able to do it? The machine is learning from the huge amount of previous stock market data or the weather data, and then it is able to do it. We also have speech synthesis, speech recognition, which we call as natural language processing, and we can do a lot of activities. There is an excellent kind of video on YouTube you can see where our Prime Minister Modi ji is speaking in Hindi, and the CEO of Facebook, Mark Zuckerberg, is speaking in English, but both are able to communicate with each another utilizing the speech translation. Speech translation is a part of speech recognition. In case of speech recognition, we have even author recognition. You identify who is the author, what he is speaking in which language, and we can also convert it into one to another. So from text, Bengali text to Hindi text to English text, we can keep on changing. Moving forward, we also have robotics, fraud detection, and every day whenever you are purchasing something on Amazon kind of platform, you can see different kind of products are shown you as a guideline that you might be interested in purchasing them. They are basically done based upon your previous history or the type of product just now you are going to purchase, how the other customers have shown their behavior who has also purchased this product. This kind of activity is today possible with the help of machine learning. Types of machine learning. We have supervised, unsupervised, and reinforcement machine learning. Out of them, in the left side, under the supervised, we have regression, decision tree, random forest, classification, and different other techniques and algorithms. Out of that, we'll be discussing today the decision tree, a tree which helps you to take a decision. Under unsupervised, you have clustering and few algorithms, and association analysis and few algorithms. And we have reinforcement, where you apply basically the agent concept. We'll see that three definitions separately and then finally come back to decision tree to understand it and then implement it with the help of Python. Each and every terminology, this slide is very important. It will be your duty if you want to make a career in future or you want to become an AI and machine learning expert, then each and everything you understand these algorithms and apply. That's why I told, just joining today's session and tomorrow writing few lines of code, you may not become an AI machine learning expert, but if really you follow for next 6 months to 12 months with this kind of concepts, every concept is available on net, on YouTube, or we can join the courses on Coursera platform. You can search through Google and understand them, listen to the videos, note down your points, and make a strong collection of the content and algorithm and their thoughts, applications, codes at your end, and implement it in daily life. Then only a journey of AI machine learning is possible. Dear listeners, viewers who have joined me in this session, please understand that the journey of AI and machine learning has been started. So just normally writing C, C++, Java code may not be enough to get a better job. It doesn't mean that they are not required anymore. They are not good. This kind of technical programming languages, subjects like software engineering, operating system, computer networks, always will be the foundation of computer science. We need to be good enough. But at the same time, if we want to make a better career, the time has come that AI machine learning is taking the shape. Giving you some examples. Where might be the best job today for a software engineer or the people like you who have joined this session that you can look for a job in the world market? I'm not telling India market or Northeast market or North market. I'm telling international market because jobs are now across the borders, across the states. So just look at your mobile phone. You have Android phone, most of you, or iPhone. Considering Android as an operating system and the type of app you are installing. Today people are using Swiggy app. In different kind of cities, we have Ola app, Uber app, different kind of music app, online platform, Tata Sky app. Each one of these apps or applications have been built on the strong foundation and algorithms of AI and machine learning. Hence, once you try to search something with the help of your something like the local apps like Jugnu app or the apps, popular apps like Uber app, it basically shows you, collects your location, find out the nearest driver, and shows you couple of connections based upon the different algorithms learning at the back. At the same time, this app learns your habit, and second time, third time, when you want to book another cab, it shows your destination or something like that. Moving forward, we are into supervised machine learning. Supervised learning is a learning model built to make prediction given an unforeseen input instance. As we have already decided that machine learning is driven by data, huge amount of data. And data is not an issue as on today, because as and when you are liking something on Facebook, you are uploading something on Facebook, you are uploading picture on Instagram, you are commenting on someone, you are booking something, you are doing you're tweeting, you're following someone, huge amount of data is just get created only on mouse click also. That means if you make a like, it makes one. If you consider this one, then understand how many ones are generated across the globe. A supervised learning algorithm takes a known set of input data set, labeled data set, and its known responses to the data to learn the regression classification model. Here, I'll try to make it more easier for you as a novice or basic learners of machine learning. A supervised machine learning never be a learning which is supervised by human being. Don't do that mistake. Don't keep it in mind. It is not a supervised learning that there will be a supervisor. It is a supervised learning where the machine, its activity, the algorithm will be guided by a output. Let's take one scenario which will be helping you to understand. If I give a machine as an input of different kind of handwriting of the 20 people today joined with my session, and I train the machine along with your handwriting, and then I make classes. How many? 20 classification. This is belong to Gautam, this is belong to Siddhartha, this is belong to Saurabh. Like that, we classify the handwritings, the data sets, the pattern of our handwriting is captured. So we keep them, we save it. Tomorrow, a new handwriting, see that, given an unforeseen input, which is not seen. So I have trained my machine. It is a supervised learning because it is guided by the classification. Already pre-built classifications are there. How many classes? 20 classes. Trained by what? Trained by our handwriting. Now a new handwriting is added and try to identify whose handwriting is that. If you are able to do it, if you can classify in which class it belongs to out of this 20 handwriting, we can call it as a supervised machine learning. I think now you will be much better to understand. Takes a known set of input data set, labeled data, and its known response to the data to learn the regression or classification model. We'll not discuss about regression today. We'll discuss about the classification. So you are classifying to a which is going to belong to a pre-decided classes. We'll see more in details about supervised learning. You can see the huge amount of raw input data. You can also see that is the activated algorithm. Whereas there is a concept of showing something like supervisor, training, data set, and the desired output. This kind of activity, without the help of a human being, the concept is going to be embedded in the center circle in this system. It is not supervised by human being, but that kind of concept, that it is something like that, is going to brought the concept here with the help of algorithm, and then data will be processed, and there will be, see, already predefined classes are there. We have a red class, green class, and we have a violet class. So, but when the data is coming, different kind of colors of data is there. Which class who will go, already predefined classes are there. So it is going to be divided into that specific classes, red class, green class, and violet class, and data will be sorted for you. Now, going to the next one, unsupervised machine learning. Unsupervised machine learning algorithm infer patterns from a data set without reference to known or leveled outcomes. If you see the previous one, there was a leveled outcome. What is a leveled outcome? Red level, green level, and violet level. But in the next case, you don't have levels. There is no predefined classes. Then how it is going to do? The algorithms will find the patterns and make cluster. Always will remember, in case of supervised learning, we use the term classification. In case of unsupervised learning, use the term cluster. So class is something which is predefined. A cluster is something which will be defined on the run. Collect the data by the algorithm. If they are common in nature, make them a cluster one. Again, some different kind of what you can call data is there who are common in nature. Again, group them together. It is something like, let us take a real life scenario when you are in your college and you have first year, second year, third year, fourth year. And first year, again, you have 1A, first year A, second year A, third year A, same as fourth year A. Again, every year you have A section, B section, if something like that. So already classes are defined. And new students come based upon is a first year entry or second year lateral entry. We can put him in a specific class. That is a supervised kind of activity. Already classes are predefined. In case of cluster, it is different. The cluster is something like that. A huge amount of people came to the college or any gathering, and we told that, okay, the red color shirt wearing people go in a group. So they make a new cluster. There was no red color class before. Suddenly we saw different kind of colors are there. We got a thought in mind. Then yellow color shirt go one side, green color dress go one side. So we got 3 clusters. No level data set, no predefined classes. On the run, by the algorithm, make the new collection of data who are similar in nature. And we identify the unknown patterns in data. These red color people were not known to us. Some people, some students ask me, sir, we are not able to do it. Different kind of color people are coming. Can you do some other than color? You can do it in reference with height. You can do it in reference with male and female. You can do it in reference with age, 10 to 20 years, 21 to 30 years, like that you can cluster them. But here the sections or the groups are not predefined. That is unsupervised machine learning. So a quick brush up again. Supervised learning, predefined classes. Unsupervised learning, no predefined classes. On the run, making of the clusters. This is unsupervised machine learning. And in this case, we have a step which is called as interpretation. Unknown output, no training data set. We are not training and making the classes, but we are able to create some new clusters. Red cluster, green cluster, and violet cluster are not predefined. It happened on the run. And this interpretation, which I was telling, something like you are interpreting with the help of color, in the help of what you can call religion, with the in reference with their age, in reference with their gender, if it's a human. In case of data, then of course, again, we can do it in a different way, finding out the similarities of the data or data set. In case of reinforcement machine learning, is a type of dynamic programming that trains algorithm using a system of reward and punishment. Reinforcement learning algorithm or agent learns by interacting with its environment, and it is agent driven. We'll be not going much into this definition and activities more today, because we will be following a particular path which is from supervised learning to a decision tree. We'll get back in some other session to understand more about reinforcement learning. We'll be entering into now decision tree classification. As we have already seen what was the position of decision tree, that it is a part of supervised learning. And see here, we have a tree which help us to take a decision. There is some questions in every layer, and we are going to find out whether a person is fit or unfit. Some specific, what you can call, parameter will be identified among the data set and then will be applied to divide the data in every layer into 2 layers. Then we suddenly told, okay, you have a lot of people. Is the person is fit? Let us identify from the age point of view. Less than 30, yes, go to left side. If it is more, go to right side. Less than 30, does he or she eats a lot of pizzas? Answer is yes. Yes, officially or unofficially, might be unfit. There might be many more layers you can add with the help of questions. Something like, does he or she involved in exercise? Does he go to gym? These are the type of question can be added in the next layers, and we can see that the tree can become more complex and deep in nature. And finally, the leaves, the leaf node. You all are from computer science background, so you know what you mean by leaf node. I am not explaining now. The last node will help us to give a decision. That is the basic concept of a decision tree. We'll see one example of this decision tree. You can see one more example. Gender, male, female, and then height, and then less than 1.3 meter, more than 1.3 meter, greater than 1.8. Like that, we can tell whether finally a specific person, either male or female, is a tall person, medium height person, or short height person. Finally, the leaf should give us a, what you can call, decision out of huge amount of data with the help of decision tree. Let us have some more points on decision tree. A simple way to visualize a decision is basically done by a decision tree. It is a type of classification algorithm. Classification is the problem of identifying to which of a set of categories a new observation belongs. That's what I told. A new set is coming. It belongs to class A, class B, or class C. It belongs to red class, it belongs to green class, or it belongs to our violet class. The basis of a training set of data containing observations, which is called as also instances, whose category membership is known. That means when you are training, you know that this data belong to class A, this data belong to class B, this data belong to class C. And this kind of activity is today possible. The huge amount of data which is available with us and the different kind of techniques. These are not just algorithms. We also have technological advancement, and Python is one of them, where we have the inbuilt packages to create decision trees and identify the final decision. We also have different kind of other classification algorithms. It's my suggestion to each one of you who has attended my session today, please time at least 2 to 3 days on each and every algorithm and master them algorithm first, understand them like a mathematics. Most of them have a statistical concept embedded into that. You'll be enjoying it to understand their nature, behavior, and steps. Don't jump into the code to write them. If you can remember, you have the quick sort, you have the bubble sort, you have shell sort, you have heap sort. All these techniques in data structure is not just basically C. You can also develop them with the help of C++, even Java or Python. What important is to understand the algorithm, to develop it in different kind of languages. Here also I'll be suggesting you this one. Please understand and do a lot of research on these algorithms, listen to the videos, and don't leave them. Let it be 3 days or 4 days also to master the understanding of the algorithm. How do they work? What are the different parameters? What they need as an input? I'll give you one simple example out of it. Many of the terminologies today maybe not clear to all of you. If you see from syllabus point of view, you might be telling, we don't have so many things in the syllabus, for then why I should learn. But see one example as the last part one, which is a neural network. We call it as an ANN, artificial neural network. In case of artificial neural network, today the deep learning is possible. In our earlier sessions, we have seen artificial intelligence, machine learning, and deep learning is the today's world. Deep learning is one of the area which is very much used in automated vehicle. And you know, once we speak about automated or manless vehicle, what is going to happen there? That happens with the help of artificial neural networks. How to develop them? You have a lot of courses, understanding based upon Python, and the important platform which is called as TensorFlow by Google, which is a free platform. We'll see some of the free platform today, and you can also use such free platforms to develop and understand the concepts. So in one way, I will tell, prepare yourself for academically, score well, and get your degrees. That's fine. But another side, each one of you should prepare for a future which is demanding at this moment a proper knowledge of AI and machine learning to have better job. Let it be Microsoft, Facebook, Twitter, Uber Lab, let it be your Google. What are the top level companies are there? All their application is AI machine learning. Don't go far. Just think of the Google application, which is driven by natural language processing. Today, you can type some one or two words in Google. The next of the words are basically predicted and it guides you. That is the natural language processing. You can even also in Google, you can also try to translate from Bengali to English, English to Hindi on the run with the help of Google Translator. All these things are possible because Google is using huge amount of natural language processing, which is basically done by what are the different kind of algorithms you are seeing in different kind of levels. I'll not spend much time on this and we'll move forward to our next topics. Let us see what are the application of classification algorithms. And as the decision tree is a classification algorithm, so these are also used in different kind of fields. So already told about the self-driving car or manless vehicle. Spam email filtering. Every time you can see whenever some mail comes, you are doing actually a machine learning activity every day. I don't know how many of you do. In Gmail, after selecting some mails which are not related to you or not of any use, you can just click on an icon which calls that it is spam. You can delete also, but make it spam. Delete means they can again mail you back as a push mail. But if you make it spam, it will go to your spam filter. So identifying some input data, which is your email, is the best example of supervised learning. You are making your Google email box to understand that it is a spam mail. Tomorrow, a new mail comes to your mailbox, which belongs to this category, is identified as spam. Detecting health problems, facial recognition, speech recognition, object detection, sentiment analysis are also the area of classification. Just taking randomly one terminology, sentiment analysis. You have a lot of collection of Twitter handler, and these Twitter handles you can collect as a collection of text data. There are a lot of data sets which are already collected by different people. You can download them because AI machine learning and basically machine learning is not possible as long as you don't have that data set. So after collecting the tweet handles, if you can analyze and identify which is a good comment, which is a bad comment, which is a happy comment, which is an unhappy comment on a particular what you can call portal or topic or for a company. Just consider there is Swiggy, and Swiggy has their own Twitter handle and there many people are commenting. And then if you can identify their sentiments, that how many people are happy as on today? How many people have given us good comment? How many people have given us bad comment? So good comment will go in another direction and bad comment will go to the manager so that you can address them. Someone told that today this food was not good, today delivery was not on time. So you can pre-classify them, and that's where classification algorithms coming into the picture. Type of classification: binary classification and multi-class classification. When we have just two categories, we can call them as binary classification. If you have multiple classes, it is a multi-class classification. Now we will be slowly moving forward and taking you up to a level of today's most interesting and important part, where you'll be seeing me in front of your eyes developing a simple decision tree with the help of Python. And that will also in future will help you to start and working and making your first machine learning algorithms or code. A machine learning model refers to a mathematical configuration that is built using previously seen data and is set up to predict new data. So mathematical configuration, previous seen data, set up to predict new data. These are the major things you do in machine learning. Machine learns from previously seen data. You apply mathematical configuration or algorithms or models, and you can predict with that when you give some new input what it is going to do. So these are the steps: data exploration, data pre-processing, splitting data for training and testing, preparing a classification model, assembling all of these steps using pipelines, training the model, running predictions on the model, and evaluation. These are basically in details here and there. One or two small steps we may avoid for the beginner learners and try to make the steps so simple for you today in the implementation using Python. But the basic steps will be remain same. We'll be in need of a data collection. We'll be taking a data set. I've made a data set for you, which is a COVID data set, and to identify whether with some specific parameters, can I tell a person is COVID affected or not? So it will be very interesting. And randomly just I have taken some data. We are not taking any real government data because we are using for learning. Data pre-processing is required. I'll show you today which will do it by hand, because as for a beginner learner, it is easy to do by hand. In future, once you learn Python well, you can do the data pre-processing. Data pre-processing is nothing but to bring it into a particular format which can be understood by machine or algorithm. This is very important. The third one, splitting data for training and testing. So once I have the pre-processed data, I'll divide it into training data and testing data. Training data will be 80% of the data, basically as a thumb rule we use for training, and 20% we test that the training algorithm, after training, the algorithm is working properly or not. What it is going to do, it is going to predict, it is going to tell, okay, this person having COVID affected or not from my data. So it is very interesting. To do that, we need to have preparing a classification model. So what model we will do today? We will do decision tree classification model. Assembling all these steps using a pipeline may not be clear to you now what you are trying to tell. Once you have more understanding, you will understand. Then we will be training data. For training the model, which model? Decision tree model. Which data will use? The 80% of the data we'll be using. From where this data come? From my collection. What I have done with the data? I have done a pre-processing or formatting of the data. So once the training the model is done, then I'll just predict. For prediction, what I will apply? I will take the test data as an unseen data so that it will be easy for us. You can give your own data also, but it will take some test data randomly because they are already pre-processed. The test data will tell me what is the success ratio of my model. And we'll see a visualizing the data with where we have few packages in Python, which will help us to understand that yes, the decision tree has been made. So let's move forward. This is about Python and machine learning. I will not be going much deep into this today because I want that you please explore them in your free time. But these are the reasons why we choose Python for machine learning, because C++, Java basically don't have such kind of packages or mechanism. It's not like that you cannot do, but you will be struggling a lot to write a code. You'll be struggling a lot. But with the help of Python, it is going to be pretty easy, because you will be having the tools in hand which you can use directly. So inbuilt libraries, we'll be using a couple of libraries today. Then moderate learning curve, it will be very fast that those models will be learning from the data. Easy to integrate, taking data from one model, handling it to another. Easy to create prototype, which we'll be doing some small prototype today, because we are not doing some industry level machine learning. Free and open source, anyone can download them and start using Python. Object oriented paradigm, already you know, C++, Java, Python belong to them. Probability, this is the language which tells about probability. It tells about that tomorrow it is going to rain or not. It is going to tell you that this person is COVID affected or not. It is going to tell you India will win the cricket match or not. It is going to tell you who is going to win the next election from data. High productivity, whatever will be your time and data investment, the money the company will invest, the political parties will invest, you as a developer will invest with the help of algorithm techniques, is a high productivity. It will show, it will make you mesmerized in the coming days once you start working with this kind of environment. Platform agnostic and more like different kind of platform it will be working with, and help you to understand whatever you develop in different platforms can bring together and give you a solution. So see, slowly we are moving. It is shown as a Python 2.7 and above. Now Python 3 is there in the market, so it will be useful for you. We'll be using basically NumPy. SkyPy is not required for us. Matplot library is a library to do the plotting, which will help us to do the visualization of data. We'll be using pandas. We'll be using scikit-learn, to where it will be having a classifier. So they are ready to use. I just need to know how to use them. More about these terminologies are going to be clear once I use them in my program today. So don't take tension. I'll be again telling about them once I write my code. Now, sir, where I'll be writing this code, how to work with them. There are two ways to handle this scenario. That means once you go ahead with learn, I'll be suggesting this. Go to this platform website, anaconda.com, and just download Anaconda latest version and install it. It will make you the coolest AI machine learning developer. It will take 80% of your tension with it. If you just start with installing Java, installing Python, taking some packages, considering it, it may take a lot of time. The Anaconda is a platform which will help you to include the basic Python libraries, the machine learning libraries, and a platform to code. So if you are aware of the previous popular IDEs, integrated development environment, I think most of you are aware of at least about NetBeans and Eclipse. They help us to create website, making the connections of to different kind of pages, database connection under one umbrella. Otherwise, if you want to develop some website by your own using some HTML and taking a Tomcat server, starting the server, adding data into that, it takes a lot of time. At the time the IDE, integrated development environment, came into the market, the website development has become more easier and excellent. Different kind of websites, excellent experience for the developer, and different kind of websites have been developed in so many years. So this platform Anaconda will be helping us today to develop our AI machine learning programs. Or in a higher level, once you become really good and you gain confidence at your system, I will be suggesting you the Google CoLab. It's a free lab where we'll be getting the total environment of AI and machine learning and different kind of other packages. You can see here Jupyter Notebook, TensorFlow with the GPU, not only CPU, it help you with the free GPU, Python data science, and different kind of environment will be helping you, and it will be helping you to connect also with GitHub. And once you develop your small mini projects, considering starting today, I'll be expecting after at least 3 months, you people will start developing your mini projects and major projects one day, and you'll be keep on adding in your CV or biodata, and there you can give these links and share your work when you get a client call for interview and all. So Google CoLab is another online environment which you can use, and it looks like that. Today I'll be not using, but you can see, if you can see at the right corner, I have logged in with my Gmail ID. So same as you can with your Gmail ID, you can, or Google ID, which is a common ID, you can log in, and that will be taking you to this environment, the same environment of Python. And the notebook we use is called as Jupyter Notebook. In that Jupyter Notebook, we'll be writing the Python code. So what is the solution? Either in an Anaconda platform, in a Jupyter Notebook, write your Python code, or go to Google Colab and open, and you can see it is mentioned untitled.jpynb. That's how the extension is, that IPynb is your notebook abbreviation, like .doc, .xls, .doc. You have IPynb is an extension of your notebook. And if you are saving a file here in the Jupyter Notebook, you can also open the same file, downloading the file, and you can open it in your own system using Anaconda. Opposite way, if you have Anaconda and you are writing some Jupyter Notebook code, the same code you can open in your Google Colab for future. So we can download from CoLab or upload from computer and make our own repository. After working also, your programs will be saved there. So these are the two environments I'm suggesting you to develop your code. Moving forward, once you know the environment of work, the most important for us is that about the data set. We'll be in need of a data set to work upon. We can create our own data set as a learner, or in future we'll be downloading the data set. Normally the data sets are in CSV format, which we call as comma separated values. It's pretty easy to develop the .csv files. Just open Excel and then you enter the data and then save the file as a .csv file. It will give you a CSV file. Or in the opposite way, if you already have an Excel file, open it with the help of Excel and resave it with the help of .csv file. When you become a good developer, you'll be in need of huge amount of data set, which you cannot do it by your own. You need to download. Like Tripura agricultural data set, let us consider. International COVID data set, let us consider. Cricket data set. Like the data sets are already available to use. And remember, just the data set will not work. We should also need the data set which are ready to use. Hence, we require the predefined and filtered data set. So the research community of AI and machine learning has kept different kind of data set to be used by the other developers, where you can save your time. If you take a new data set, you need to do data filtering, or you also call it as data munging. There are a lot of steps which can be done with data, but there are data set which are already pre-filtered and I can use in my work. But today I'm not going to do that. Today I'll create my own CSV file, and that CSV file I'll be showing you will be used for our prediction. So let's move forward. Sample COVID mock data set. You can see here, and that is made by me just for you people so that you can understand. I have not downloaded it. There are just, you can see some 19 rows are there. And let us see how many columns. 1, 2, 3, 4, 5, 6, 7, 8 columns. And last one is called as a class. Finally, the class is 1 or 0. If it is 1, then I can tell with this kind of option. Let us see the data set properly, because for a developer, the understanding of data set is very important. If fever is 102, cough is yes, age is 30, some data, it's not like that, some patient data has been identified. Weight loss was there, yes. Duration for 2 weeks. Which city it is found? Hyderabad city. Male or female? Male. Breathing problem was there, yes. And we have found him already COVID class. You are not identifying it as is already tested and found this patient having COVID. Another, C, this person having fever 98, but cough was there, age was 32, weight loss was not there. Last 3 weeks he is suffering from cough problem. Same city, male, there was no breathing problem. He also did not have COVID. So that's how this data set is made to understand by the novice learners like you, where you can create it with the help of Excel sheet and save it as .csv file. Don't forget. Now let us see the next part of this data. See the previous part and see the next part. The most of the machine learning tools which are developed in Python, the models are ready to use. We'll be using a decision tree model, which is a library. It's a collection of code. It will do it for you. You don't need to write everything for it. Something like if you want to print something in C on the screen, it is printf. You don't need to take much tension. Call the predefined function printf and do it. You want to scan something, call the scanf function. You want to do it, same thing in the Java system.print.outline, println, system.out.println. It will be helping you to print a value on the system. Like that, there are predefined things which are already kept. Same way, we'll be having predefined model which will be helping me to take the data. So what is the difference between the previous data and this data? This data all having float values. And even the city, if you see, wherever earlier city, Hyderabad, Agartala, AGT, we have given some values to them. So if Agartala is 20.0, you see 20.0, wherever it is there, it is Agartala. 10 is for Hyderabad. 30 might be for Bangalore. So 30 is Bangalore, like that. So handcrafted data, I always tell, because we have learned step by step in a longer term. I am not a student of AI machine learning who has completed AI machine learning in engineering and learned everything. We have learned everything our own. Slow learner, long-term learner, understanding from different kind of videos, sessions, conferences, articles, research papers, made my own understanding. One understanding which I got and sharing with you, that is that the basic data sets should be handcrafted. You create your own, and so that you can have an idea that when some prediction is going to make out of it, then whether it is correct or not. So you have converted this data set into a float. Everything is point something. So the COVID class already was 1.10 and all this, you have converted it 1.0, 0.0. So after making it, the data by hand, I have converted it to float. You can do it with some Excel parameters. If you're expert in Excel, do it. But totally, it is done by hand. An interesting part is that once you learn Python in a proper way, this is basically called as data interpretation or data filtering. You can also remove some of the field out of it, or some records, in a record, a row, you can delete it, considering in some state, let's consider this data is collected by central government. In some state, some 2-3, what you can call a patient's age is not entered, or fever is not entered properly, 202. Actually, it is supposed to be 102. The data is entered as 202. Coming from different villages, different districts, huge amount of data. Today, 25,000 people are affected. So just think they have such kind of Excel sheet where 25,000 data is there. Out of 25,000, there might be 100 or 50 entries in your CSV file which are not correct. How do you remove them? That is called filtering. So in Python, using pandas, you can remove it by writing code, which is not a part of today's discussion. But you can take out unwanted data also. At the same time, you can also move forward and convert the data into floating values, everything in floating values. Otherwise, your programs will not run. Remember, if you're not converted into float, it will not work. In future, you need to learn using pandas how to remove unwanted data, how to do proper filtering, and how to convert data into float. And that is called as data pre-processing or data munging. Moving forward, this might be the kind of things which is going to happen from our data. It's not a perfect tree, but considering, see, there are different things where male, female was there. Are you going to divide it? City should be the first node, and considering city-wise tree, I will make in the level 1. Or no, we'll go first by the age. Here we have gone by male, female. No, we'll go by age. You have already seen one example by age, that whether the person was fit or unfit. Here it is question is the person is COVID affected or not. We have taken randomly one idea here that might be by male and female, and then see the age again above or below something, and then based upon the breathing problem or something. All the layers I have not shown here because it is not a perfect tree. You can start thinking of your own tree. Dear viewers, you'll be excited to know this total things which I have done in handcrafted is going to be done by that classifier, that model decision tree classifier, which is a part of Python. It is going to do it for you. You don't need to take any tension. It's already told. We'll see a demo also. Basically using Anaconda or Google Lab. I'll be choosing Anaconda for you. Coming back, because we are going to implement now, we have seen the data set. This is what is a decision tree. Every layer you can see. Finally, the leaf node will be having some solution. Let us understand the algorithm a little bit before we write the code. The basic idea behind any decision tree algorithm is as follows. Select the best attribute using attribute selection measures, ASM. So we have taken a best attribute here, something like male or female. A gender has been taken here as an attribute. In our case, it will be done by the machine or program. Make that attribute a decision node and breaks the data set into smaller subset. So we have divided into two small subset, male and female. Starts tree building by representing this process recursively for each child until one of the condition will match. So recursively the tree should be built, and this condition still it is not. It is matched. All the tuples belong to the same attribute value. There are no more remaining attributes. That means every attribute is considered, and there are no more instances. Every data field, everything has been considered. Every leaf we have reached, as long as it is not happening, it will be going on. And the time it's all about recursively, you know what we are trying to mean. Like you can write a recursive program in C to do some bubble sort. You can do it without recursion also. The same way, with the help of a recursion, every data given as an input will be considered, and then the tree will be built. Again, I'm saying you no need to do anything. You just need to represent the data in a proper way with the help of few lines of code of Python to call it, and then see how it is happening. How it will do that? Then data is there. We'll be giving the data set already you've seen. So the left side, this one already have seen our data set, how it looks like. With training data and test data, the data will be divided into two parts, training and test data. Training data is 80%, test data is 20%. And then a decision tree generation will be done. I'm not taking much time because already we are 1 hour here. So decision tree generation will be there. Who will do it? There will be a method called as decision tree classifier under Python. It will be done by that. We'll have a model evaluation, and then finally performance of the model, how much percentage of data it could do it in a proper way. If you want, you can load your own data set. If you are not able to install Anaconda in a proper way, sometimes happens, internet speed and this, that, it becomes more easier. And in that case, you can load your data set. I have just shown you my, what you can call one of the file. it is, as you can see, we have some farming data 2019.csv has been intentionally, some name also has been given in a notebook, TIT annual, something like natural language or whatever. We have given some name, and you can upload your data and start working. So the same CSV file, don't upload Excel sheet. You see all my files whenever I am working, all other files, you can see most of them are in .csv file. You need to upload your data in .csv file and go through some tutorials how to use Google CoLab. Free tutorials are there. Let us go to the most important part, that what we told, that it is the way to give you a chance to understand. I have spoken with Great Learning, and I have created the free link for TIT, which I'll be sharing with you, and you will be able to see. You can see there in this link itself, your name is embedded. So you'll be given a separate account. You need to register, and you can start Python for machine learning, the machine learning foundations, and introduction to our excellent programs, free of cost for the you people. I'm giving it as a part of my student. So go ahead and learn them. I'll be sharing this link soon. So let's code Anaconda, Jupyter, and you people and myself. Let's code now and see that how to develop a decision tree and get some decision in next 10 to 15 minutes. So that's where I stop the first part of this presentation, and then I'll be taking you to the next part, which is nothing but working with the what you can call Python, and I'll be using my Anaconda environment, which is installed in my machine, and sharing with you. So are you enjoying? Can I get some yes at this junction? Because it's not easy to speak for 1 hour constantly, and also happy to getting such what you can call listener across state with me. So can I get some yes from you? We are able to understand what I'm speaking. Yes, very good, very good. Thank you. I already seeing some yes, very good. And next part also is going to be very interesting, which I'll be concluding by 10 to 15 minutes, and assure you that you will understand. And also in the next level, we'll be helping you to go ahead and support you with the code so that you can start in a particular junction. So what is there for us in the next? In next is there, I'm going to share my screen once again, and this time I'll be taking you to my, so I'm closing my video, and I am taking you to the environment of my local host, which is hosting the Anaconda. And from here, I'm going to create, so I think you can see, I can going to open from new Python 3. So that will be creating my Jupyter notebook. That is my Jupyter notebook. So hope you are able to see my notebook on the screen, and here we'll be writing our code. So already for your understanding, I have done and executed, because we cannot spend so much time on online to write, type everything. So what is there is that, let me file and open, and from there I have created a file here, which is my Jupyter notebook file, and that's how it looks like. It is open in front of you. What I will do is that they're already executed code, but I'll take small part of code and implement for you so that you can understand. So as you know, the hash is for comment. You are supposed to type it, but I'm taking it for you in a new Jupyter notebook so that I can show you. So this is the part of code, and I'll just make it a little bigger for you. So that's where we are. And so first is that loading the packages on Jupyter notebook, import pandas, numpy, matplotlib, and make the things inline. We'll not discuss much of it because there are a lot of content and videos are available on this. To tell you in a simple is that the import pandas, it is something like hash include standard io.h, hash include conio.h, because you people come from C data structure and C++ background. For you, you'll be easy to understand too. So there we have libraries And here also we have the pandas, NumPy as the libraries, which will be helping us to do the work. So pandas is basically to take care of the different kind of tables, and NumPy is to take care of different kind of arrays, and you have matplot library to take care of different kind of plotting. So that's for time being. We have a run button. You can run it, and the code doesn't showing, it is not showing any error, means my code is fine. Let us move and see the next part of the code and what we have. So we'll be loading the CSV file, and already you have seen my CSV file. So once again, I'm pasting it for you. See loading.csv file or the data set, and we identify the data set as data frame DF. So DF, I'm defining DF as PD. PD you know already. So for as a beginner learner, I'm saying, you know, the PD is the reference of pandas. So PD is pandas, and from with the help of pandas library, read the CSV file. Read CSV is a method. So all are predefined. You need to only give the path. This path you need to define. Where I have kept my covid1.csv file. The COVID file was the basic Excel file, and the covid1.csv is the second file where you have seen I have converted everything into float. Let us run it. So my data is now loaded into the machine, into this platform, into this Jupyter notebook. My data has been loaded. Can I see my data in a particular way? It is loaded or not? So to display the data, it is just df. Just df is the command. So df will bring this df and I can have the display. So see the next, if I run, it displays the overall notebook which I have already created. So the notebook is in front of you. How I got it? A small command, only the name of the data frame. df is from data frame. Again, I am saying, if someone was not able to understand how I got the df, I got the df with the help of pandas, and I have read the CSV file which was already created by me. What is the name of my CSV file? covid1.csv. So at the very beginning, I need my libraries, which is already shown. Second step, I need to upload the data in a data frame, and then I can also see how the data frame looks like. As it is a small one, only 19 records are there, you are able to see. In case of 2000 or 3000 or 20,000 records, we apply a small technique. What are those techniques? Let us see. So we can apply df.head, which will be showing us the first 5 rows. The first 5 rows I can show with the help of df.head. So I'm going and running it for you. Here, df.head, the head portion. How many rows it is going to bring? Only the first 5. There might be 25,000, 20,000. It will bring only the first 5. So let us run it. See, only the first 5, 0, 1, 2, 3, 4, first 5 records have been displayed. So fast it is working. Let us move next. Can I see the last part of the code? Yes, you can see the last part of your data set with the help of df.tail. The df.tail will bring the last 5 rows for you. Let us see that. So run it, and it brings you the last 5 lines, 15, 16, 17, 18, 19. Last 5 rows is displayed for you. Let's move forward. Can I know more about my data set? It is dataframe.describe is the command. Describe method. Describe your data. Please understand what you get about it. This count, mean, standard deviation, percentage and all. I'm not going to explain today. It will be a different class altogether, but you can do it by your own. But I'm just showing you how to execute the command. It is not related to decision tree implementation, but this is a Python data set command which we use to understand our data in a much better way. May not be just required for decision tree. It is required for other what you can call implementation also. So I'll be taking this one, df.describe, and typing it here for you. I'm just pasting for first. You should type it and run. So it will give you the description of your data set. I'm omitting it intentionally. I'm not going deep into that now. I I can know more about my data, how many, what you can call rows and how many columns are there. Very simple command, data frame dot shape. It will show you the number of rows and column. Data frame dot shape, run. See, so fast, 20 rows, 9 columns. Very good. Let us move. And now time has come. Let us take a little breath. We are going to divide our data now. And before that, how? Dividing our data into attributes and levels. Attributes is the all the columns other than the last one. Do you remember what was the last column? It was the class, COVID class, 1 or 0. If it is COVID affected, it was 1, not affected 0. Other than that column, all the remaining part, X, all the columns of DF, all the columns of DF, just have a look. All the columns of DF here, fever, cough, age, weight loss, duration, city, gender, breathing problem, COVID class. We'll not take the COVID class, we'll take all the remaining heading fields, and that will make us make our part X. So dividing the data into X and Y, X is the part which is the taking all the fields other than the last column, and Y is the COVID class. So the column with values, that means it will define which is the classification column. The last column is the classification column. Which classification? Class 1 or class 0? 2 class. By classification. So how do you divide the data now? X is equal to df dot drop and drop COVID class, and axis is 1. For time being, not much understanding of axis 1. Keep it as it is once you code. But we are dropping the COVID class. Drop the last column. So drop COVID class. And this COVID class is Y. So you are dividing your data into X and Y. X is the collection of everything, every column, and Y is the last column or the class. So let us run it. If you leave a step, then the next step will not work. So Control C, Anaconda, Control V. Let us run this run. So no error, fine. If you have error, it will be showing you. And then you can, as for example, how the error comes, just for you, I'm telling it is not there. So run it, she will get the error. So this is how it will be showing. With an arrow symbol, it is showing end of line is not in a proper way. So you'll get an error. Let me do it again. Now it will not show any error. So if there is an error in your code, it will be shown by the Jupyter notebook. Moving forward. So X and Y, remember, 80% of the X will be going for training data, 20% for test data. 80% of Y will go for train data, 20% of Y will go for test data. So from 2, now 4 sets, 2 sets. What are the 2 sets? X and Y. What was the first set? DF, data frame. Now dividing them into X and Y, already done. Now X will be divided into train and test. Y will be divided into train and test. 80%, 80-20 combination. And that is where from sklearn, model selection, import train test split. This train test split you are importing from sklearn. And sklearn is again, once again, a library. So you don't need to take any tension. As it is, you need to write, you need to just define your X train. These variables names you need to give. Train test split and define it with X and Y. So X and Y, let us divide it. Test size is equal to 0.20. That means 80% of data for training, 20% of data is for testing. Let us run this. So where we are now, we are there to divide our data for training and testing. So let us go ahead and put it in Jupyter notebook. So this is also went well. My data is now divided into X and Y. X train, X test, Y train, Y test. Remember, 4 sets of data in my hand. Where it is? It is with Jupyter notebook. Fine. Moving forward, now we bring and we help the final step, train the decision tree algorithm on this data and make predictions. So first we'll do the training of the decision tree. And let us take this part of code and I will be explaining you here and see it. We are in the final step What we have in your hand? 4 set, X train, X test, Y train, Y test. You have it from where? From X and Y. Where you got X and Y? From data frame. Where you got a data frame? You got the data frame from your data set or the .csv file. So remember it, get it in your mind. On this data, we'll be applying a decision tree classifier. So here is the decision tree classifier method. This decision tree classifier method will be doing the task and take the X train, Y train. The classifier, which is made an object from decision tree classifier. Classifier is made from decision tree classifier, and it will fit the model with the help of only training data. I will not bring the test data here, X train and Y train. So I'll be training the model. Which model? My decision tree model. Who is building it? You are not building it. The decision tree classifier method is going to build it. Where you got decision tree classifier? In sklearn. That's how our learning should go. Let's run it. So our model is built. Lot of message will come. At this moment, I am not going into the what is the result you got. There is no red mark. There is no error. There is a result. You please see it in your free time. My model is ready and the decision tree has been trained by X train and Y train. I want to move it to the next level and see what is there. Don't think of code. Every code I will be giving sending for you. So let's make the prediction on test data set. So Y prediction, I'll be going to make Y prediction. And this is where the actual part comes. Can it predict something? Why? What I am providing in X prediction, a Y prediction? I am going to give the data which is left out. Remember, you have used the X train data for training the model. You have not used anything else. X train and Y train have been used. This is the time has come. X test will be used. And what is the expected result? It is there in Y test, right? Already we know the classes. So this X test is not used for machine training. It has been kept separately. Which one? 20% of the data. Now we are going to apply it with the help of Y prediction and calling the classifier, handing over the next part of the data, 20% of the data, which is X test. Already I have kept it with the help of X test. Let us run it. And it is telling that the Y prediction is also ready. But how to know that Y prediction is done? We normally find it from F1 score, that whether the Y prediction result is correct or not. So you need to understand some of the terminologies. As I told, don't have any fear, move forward, take each one and every line, just put it in Google and try to understand what is happening in every step after my classes also. So F1 score is that what percent of positive predictions were correct. Where is the prediction? Y prediction. Y prediction, how much it was correct. We call it as a F1 score. What is F1 score? Please understand. It's a statistical term, very much used in computer science, and it has a different formula, which I cannot move now at this moment. But F1 score, where you will get F1 score? From sklearn metrics, you can import F1 score, and this F1 score is going to build on basically Y test and Y prediction. Do you remember that Y test is already known to us? Y test is already known to us. We divided our data into X and Y. Then X was divided into X train and X test. Y was divided into Y test and Y train. The training data, that means X train and Y train, was used. Just now we have used X test to make the Y prediction. Now time has come. What is left out? We have not used the fourth category, Y test. Now we'll be comparing Y test versus Y prediction. How much correctness is there? So get ready and let us see the result. How nicely you have built a classification model, which is a decision tree classification, in our last almost 1.5 hour session. And this is the last moment we are going to understand how much correctness was there in my program. Let us run it. Oh, good. F1 score is 0.85. 85% of the time, my machine was able to tell that whether a patient is COVID affected or not. And that's where how the machine learning works, my dear listener, who are joined with me today at this junction in 1.5 hours. We have implemented, we have understood what is machine learning, implemented a decision tree, and finally see if the decision tree is taking a decision on some unseen data. What was the unseen data? Y test. We have kept the Y test separately. We have not used the Y test for training, remember. And Y test has checked with my Y prediction and understood that it is 85% of prediction is correct. You can go up to 95 to 98% of correction when you use huge amount of data set. We have taken a very simple, only 19 records were there, 9 columns were there. Based upon that, I have tried to build the easiest, what you can call, decision tree for you, where I can give a demonstration. Just think about your real life. If you can download the real data set, which is available inside 25,000 patient data, and then tomorrow a new patient come with all these symptoms, you can tell whether it is COVID affected or not. So excellent way of understanding. And let us see the last part. You can also visualize that how a decision tree was actually framed or formed in our presentation by decision tree classifier. Remember, this decision tree classifier was used. This portion of the code will help me. So sklearn is coming. We are importing tree, which will help me to plot the classifier, which has been built by classifier. You have just given the inputs and it will be showing. See, we got our tree. You need to have time to understand each and every, right? But where we started, we are now making a connecting the dots. We can see a decision tree, and as you have already seen, there is also Gini effect, which is kept is 0.492. As I told, we are already in 1.5 hour session. So you please take those terms and understand what is a Gini effect. For a student of computer science or practitioner of computer science, it will not a big deal to understand. So that's where we had today in our session, and hope you have enjoyed. I'll be, of course, coming back on screen and speak with you for a certain time. And that's how we basically implement in a simple way of decision tree. And this, just to give you some few references, interesting tool, which is Jupyter Notebook running on what you can call Python 3.0, supported by Anaconda. You can do all your Python activity, as you know already. You can just run. In case of C program, you cannot do all this activity so fast. So you can do all your math, what you can call other programming activities here, and try to define. As you can see, I'm typing on your screen, and for the beginner learners, just to give you confidence that you can write your code. So it's pretty easy to write in code in Python, just to give you this confidence that I'm showing the last part of this coding, and don't have any fear of that, can I do it or not? First, you need to understand, yes, I can do it. It's like something like you're writing a cycle, and then you fall down and you come back and you work with a much more confidence. So whatever the Jupyter notebook you have seen today here under Anaconda, same notebook you can see on Google CoLab, and you can start working there if you are not able to install. I always suggest to install because there are so many other things you can do with that. And that's bring me in today's session of understanding machine learning and working with the decision tree activities. And that's how we'll be closing the session